All right, number 4. Marcus is making an open top box by cutting squares out of the corners of a piece of paper that is 8.5 inches by 11 inches, and then folding up the sides. If the side lengths of her square cutouts are x inches, then the volume of the box is given by v of x here. Marcus graphs v of x along with b of x equals 50. So this right here, this is the red graph. So this is the red graph, and this is the blue graph. Okay. So A, what is a reasonable domain for v of x? So what is a reasonable domain for the red graph? If you forgot, this is way back from the beginning of this unit. But it turns out you need to look for the two x-intercepts where the graph is completely positive between them. So I need to look for the two x-intercepts where the graph is completely positive between them. So that's going to be these 2 points right here, 0 to 4.25. So the reasonable domain is between 0 and 4.25. That's how I figure out reasonable domain. Okay. Part B. Approximately what value of x will give him a box with the largest volume? So the largest volume is going to be up here. What x value will give you the largest volume? That's going to be x equals 1.585. C, based on your reasonable domain of v of x, approximately which values of x is the volume of the box increasing? So the volume of the box is increasing between 0 and 1.585, and then it decreases to the end here. So approximately which values of x is the volume decreasing or increasing? It's increasing between 0 and 1.585. And then D, what do the 2 points of intersection of v of x and b of x shown above represent? So that would be this point right here and this point right here. Keep in mind, this represents volume, okay? And this graph right here was 50. So these 2 points of intersection represent the points at which the volume is 50. So what do the 2 points of intersection of v of x and b of x shown above represent? They represent the points where the volume is 50. Now in this case, x is your size of square that you're cutting out. So in this case, it's going to be the square cutouts that give you a volume of 50. So what do the 2 points of intersection shown above represent? They represent the square size, the square sizes, the square sizes that give us a volume of 50.